Welcome. Having gotten introduced to Spark SQL and done a hands-on or at least seen a demo of how we can use the data definition language, the DDL of your structure query language. So in this module, we will now go on to use Spark SQL in PySpark, right? So first we are going to look at what is the key difference between Spark and PySpark, right? How are they different? What are similarities? How should you look at each of them? And then we are going to take a deeper look at RDD, which is the resilient distributed data set that we talked about in earlier week's module, versus DataFrame. The concept of DataFrame we are going to get introduced to. And then we are going to talk about this Spark SQL execution plan. So this is how, when you run a Spark query, right, on your Databricks, how the execution happens. What are the steps of this execution plan? We are going to take a deeper dive into the execution plan and understand the steps of it. And then we'll see a demo of DataFrames and the methods in PySpark. So let's get started. So till now we have sort of used Spark and PySpark interchangeably. It is just one of the language to use Spark, right? But there are some key differences between Spark as the data processing engine. So it's a general purpose open source engine for processing of huge amounts of data. Whereas when you look at PySpark, it is a collaboration of the Spark framework to work with Python language. So PySpark is an API gateway to Apache Spark using Python. So Spark is originally written in a language Scala, which is very similar to Java, whereas your PySpark is written in Python. So in Spark, your remote procedure call, RPS server, it uses remote procedure call to accept API from other language programming languages. Okay, so PySpark is an API that internally converts the program that you write into Scala to trigger the Spark session. Right, so essentially think of PySpark as a wrapper that is built on top of Spark. So Spark works on Scala, but then you have your PySpark because why? Because of this reason, your PySpark is developed to make it easy for Python developers to communicate with the Spark framework, right? Because Spark is developed to tame very huge, it's a big data processing engine. So Scala is a new language that we have to learn. So instead of just letting it to be where people wrote program only in Scala to access Spark, so the developers sort of came up with PySpark, which is a wrapper. Right, so that is the huge advantage of Spark, because you don't have to learn another additional languages just to work on this big data engine. So of course Spark uses various library imports to carry out specific functionality, whereas your PySpark, there is a Py4j library that is used to facilitate its working with Spark. So so this is the part that is important. Your PySpark essentially internally converts your program to Scala to trigger the Spark session, right? So that's why it's considered to be a wrapper. Having understood Spark SQL, a very important data structure that you have to understand is Spark DataFrame. So, although in the Spark core engine, RDD was a fundamental data structure in Spark, your resilient distributed data system, DataFrame was later developed because it created an integrated data structure with an easy to use API for simplifying distributed big data processing. Okay, so DataFrame is available for any general purpose programming language. So DataFrames is available not only on the original Spark written in Scala, but also in your PySpark, RSpark, etc. So DataFrame is essentially an extension of the Spark RDD API, optimized for writing code more efficiently while remaining powerful. Okay. So what then is a data frame? The data frame is also known as a programming abstraction in the Spark SQL module. So data frames, very similar to the data frames that we have seen earlier in your pandas when you must have done machine learning. So data frame resemble relational database tables or Excel spreadsheets with header. Right, so the data resides in rows and columns. So that is the whole idea of your data frame, because your rows, it's indexed on both your rows and your columns, right? But because it is data, it's big data, so the way it gets stored, how the data is distributed of a particular data frame, internal within the nodes are different, because it's going to use columnar based storage, right, between these multiple nodes. So but it doesn't matter, because it's sort of an abstraction to us. So we are going to treat your data as a data frame, and we are going to query it like a data frame. Internally, Spark is going to do all the MapReduce, all of the chunking of data coming from different nodes, etc. So that is sort of taken care of by Spark. So we write our program in PySpark. So there are essentially two types of data frame, right? One is your local data frame, a data frame that resides within only a single node in your distributed set of nodes. So a typical local data frame is your pandas data frame, whereas you have your distributed data frame, which is your Spark data frame. So in Spark, you can actually import pandas. You can convert a data frame from Spark data frame into your pandas data frame. The difference is, in a Spark data frame, your data frame is distributed. So if you remember the image when we looked at RDD, right? So your data is distributed, the data frame data itself is distributed across the multiple nodes. So it's a distributed data frame. That is the concept here. So let's take a look at some of the differences between your RDD and your data frame. So RDD, which is the fundamental data structure in Spark, stands for resilient distributed data set. So it's a distributed collection, right? So we have seen that in module 1. You can see the collection is distributed across the multiple nodes within Spark. It's immutable, meaning you cannot change it. So you can transform it and create another RDD. You can filter and create another RDD. So there are multiple processing that you can do on it, but in and of itself, it is not changeable. It's immutable, right? So it is fault tolerant, which essentially means there is a logical execution plan in place for any node failure. So Spark takes care of it. So in the event, in a distributed node setting, so if one of the node fails, the data frame doesn't have to, because there are sufficient replication of your data happening, etc. So that is happening under the hood, which Spark sort of abstracts from the developer, right? So it is fault tolerant. So which means it takes into account that, hey, not all the time all your nodes will be working. So there is a chance that your node can fail, right? So most of your RDD takes care of, does processing through lazy evaluation. This we have already seen. Lazy is where the plan for execution is created, but actually the execution doesn't happen. The execution happens only when you have an action, right? So your functional transformation happens as a combination of your transformations, which are lazy evaluation, where you are just planning what needs to be done, and then there is an action method which triggers the action, right? That's where it starts executing all of the plan that has been put into place. RDD, of course, can do processing of both structured and unstructured data. So one of the labs that we did in the earlier week, we looked at textual data as well, CSV data as well. So we know it is capable of doing data processing of structured and unstructured, and the programming language support for RDD is all of the language, Scala, Java, Python and R. So now let's look at your data frame. So data frame came after RDD, right? So data frame was meant because it is easy to use, and developers are already used to the concept of data frames, right? So what is data frame? It's a distributed collection of row objects. Okay, so it's not just collection, but collection of structured data in terms of row objects. So there is rows and columns. So when you work with RDD, there is no infer schema available in RDD. But whereas in a data frame, there is an infer schema where you can actually infer the schema in order to read your data into your data frame. So data processing of different formats of your file, right, becomes easy because you can load data from your JSON, CSV, Parquet files, etc. into data frame. So optimization happens using what is called a catalyst optimizer. We'll talk a little bit deeper into this in the subsequent slide, right? What do we mean? Because that's the execution plan that happens in Spark, right? So optimization happens in a data frame, and because of its familiarity with developers, right? Spark has ensured that there is a lot of query optimization, all kinds of optimization that happens in your data frame as well. So it makes it fast and efficient internal representation, right? So because working with RDDs might get a little bit challenging, right? Whereas data frame is something developers have worked on while doing your exploratory data analysis using other packages like pandas, etc. So a lot of those functions are sort of ported into the use of your data frame methods here in Spark. So in the earlier slides, we talked about optimization that Spark does. So Spark typically has a logical and physical plan in place. Right. So when you write your SQL query, which we have done in the earlier module, in this module we will talk a lot more about data frame. So whether you are writing a query just as an SQL query or writing a query using the data frame, so Spark creates a logical plan. So first so there are several steps to the process. So first you are writing code. So code can be either data frame or SQL, and then we submit it to Spark, right? So submitting it to the driver program, just to be very reiterating it. So if the code is valid, Spark will convert it into a logical plan. So of course validity is checked by syntax, etc. If all of the objects are defined, all of that, right? So then comes Spark will pass the logical plan to the catalyst optimizer, where majority of the optimization happens. So what happens is first, a unresolved logical plan happens. Okay, so an unresolved logical plan is put into place. So let me highlight that, right? Then it uses the data catalog, right? The schema information. So because first it doesn't directly map the columns and rows of each of the tables. So unresolved logical plan is put into place, and then the data catalog, the meta store information, is essentially used to create a logical plan. So once the logical plan is created, then it goes through a catalyst optimizer, which optimizes the logical plan further, right? So so this is the place where majority of the optimization happens. So once the optimized logical plan is ready, that gets translated into the physical plan. So it describes computation on data set with specific definition on how to conduct the computation, right? So let's say we are performing a join query between two tables. In that join operation, we may have a flat table and a thin table, right? So the number of flat table is one which has multiple columns, and a thin table is one which has less number of columns, right, with different number of partitions. So because your data is inherently distributed, so you might have one table which is distributed across 3 partitions, whereas the thin table being distributed, let's say, across 2 partitions. So in the physical plan, what Spark does is it decides which partition should be joined first. Basically, it decides the order of joining the partition, the type of joins, etc., for better optimization. So the physical, only after the optimization of logical plan, the physical plan happens. So the physical plan is the step-by-step ways that Spark executor can essentially execute, right? So then Spark executes or processes the physical plan and does all the computation to get the output, right? So that's what happens. So once you have the physical plan, there is of course there is a cost model which says how much is this computation going to cost, and then a physical plan is selected, and then there is code generation that happens to execute it. So within the logical plan steps, there is the catalyst optimizer, which essentially where most of the optimization happens, right? So it leverages programming language features like the matching systems in Scala to build a query optimizer. So Catalyst is built on functional programming constructs in Scala. There is procedural programming, and then there are functional programming. The paradigm is a little different. So the whole idea of the Catalyst optimizer, which is built on functional programming construct, is for two things. First, the ability to easily add optimization techniques and features to Spark SQL, right? And to enable external developers to extend the optimizer, like adding data source specific rules or support new data types, etc. So that is the whole construct of your Catalyst optimizer, right? So as we saw in the earlier step, first there is an unresolved logical plan is resolved to the logical plan, and then it's further optimized by the Catalyst optimizer into the optimized logical plan. So what does the optimization actually entail, right? So the actual optimizing, what happens is it checks for all the tasks which can be performed and computed together in one stage, right? Then in a multi-query join, it decides the order of execution of the query for better performance, right? So there could be several physical sort of plan that comes out of it. That's why after the cost modeling, one of the plan is selected. So the optimization tries to optimize the query by evaluating the filter clause before the project. So just to summarize, whenever there's a query that's put together in the Spark SQL, Spark creates the logical and physical execution plan, right? So there is unresolved logical plan followed by the logical plan, then an optimized logical plan after it goes through the Catalyst optimizer, and then the physical plans comes about, right? So the physical plan is what gets translated into the DAG steps, the set of steps, your directed acyclic graphs that you see on your Databricks, right? To execute the computation itself, right? So in this module, next we are going to take a look at a demo of your PySpark, demo of the DataFrame and DataFrame methods in PySpark. All right, so let's go to the demo.
All right. So in this demo, we are going to walk through PySpark data frames and data frames method. So when we started using Spark, we got introduced to RDD. So previously, we have seen now the differences between RDD and data frame. So we are going to see how Spark SQL, right, can also manage your data frames, right? So something that you are familiar where when you have used your pandas library before. So as I said, a lot of these are compiled from Brian Cafferty's notes, right? So I'm going to go ahead. So you can load your open up your PySpark data frames and data frame methods, which is part of your Spark SQL lab file. Right. So in this, we are again going to use the uh, database that we have created. So you should have loaded the data from your all of your files, right, before you start working on this lab. Okay, so how do we use Spark SQL to load PySpark data frame, right? So the earlier notebook that we looked at, right? So that used all the data definition language directly. Here we are going to use PySpark, which is Python Spark with the Python wrapper, right? So how do you write it? So on the Spark object, you call the SQL to say use the corresponding set the database context, and then we are running this and we are saying drop NA and putting it into a Spark data frame. Okay, so SP data frame. So let's run that. So if you want to look at the type of a variable, so this is your Spark data frame, right? So previously we just ran SQL, right? We didn't necessarily, we created the SQL tables and we did joins, but we didn't bring them into data tables. So that is the key difference, right? So now if you want to display your Spark data frame, so you can go ahead and display. So that will go ahead and create this, whatever is your sales info, which is essentially select star from your fact internet sales. Okay, so now let's create another SQL. So how do you, so you put your SQL into a string, right? So if you're writing multi-line string, then you want to do a triple quote. So get US customer query. So this is what we are specifying US where only customer with certain region code. So how do you go ahead? You do Spark.SQL of get your, you pass on your query, right? So some of the data frame functions, if you want to look at it, so it will give you the set of columns, right? So there is customer key, all of it. So in some case, there might be IntelliSense where you can do a dot tab, right? So that will give you a lot of these functions. You can go ahead and try and understand what are all the set of methods that are available in a Spark data frame. So Spark data frame, as we have seen earlier, is a distributed data frame, right? So then we can go ahead and show the data frame schema, right? So where it says, hey, what's the type of this column? Is it nullable, etc. Right? So if there are null values, it would say nullable, right? Then you can do a lot of manipulations just like you used to do using your data frames and pandas. You can add columns. So you can say you just with column tax rate, and so that will have your tax amount divided by your sales amount, right? So now, if you want to display only a few columns of your Spark data frame, you can just index only those columns. So it's very similar to a data frame. So your data frame is essentially which is a distributed collection of row objects, as we have seen, right? So it's for structured data. So then, so does it mean that we can just load our CSV file into your table? Can we load a CSV file into a data frame as well? Yes, you can. But before we go into that, we are going to see, other than your select, what are all the other SQL that you can execute from your PySpark, right? So first we will create table, right? So we are going to create table very similar to the table sales info extract we had created earlier. So we are going to create a table using delta. So this is a delta table and we have to specify the location, right? So in your database, delta tables, right? You specify, hey, this is where your table. Go ahead and write it as a multi-line text. Right? So this line, if you look at it, it's doing Spark.SQL already. So we are not receiving any information from it into a data frame because it doesn't output a data frame, right? So whereas your earlier select queries outputted a data frame. So depending on the nature of query you write, you will have to suitably specify. So now that you have created the table, so this is a Python notebook, right? How do you create? It's a Python notebook. So if you want to run a SQL command, you can just specify percentage SQL and it will turn it into a SQL cell, right? So you can actually run to see, hey, did the table we created actually exist in the database? Okay, so this is not, again, sorry for the use of the language. This is not a database, but this is Spark SQL, right? So it's essentially a meta store which takes care of all the schemas. So we are creating these tables and the meta stores, the schemas, etc. in it. So whenever execution happens, the whole execution is expanded and happens. But it's important to understand this is not a database, because Spark is not a database, it's a data processing engine. Okay, so then of course you can, since we now know that a table got formed in your Spark context of a database, right? So now you can do your select star from the table that you created. Okay, so here what we are doing is we are doing a dot collect, which what it does is it actually creates a list. Okay, so it creates a list, so which is the set of all values, and this, since this is a small data set, we can convert it into a local data frame. Okay, instead of a Spark data frame, we can create it a local pandas data frame. So all that you can do is dot to pandas, right? And you display it. And if you look at the type of it, so this is a pandas data frame. So by now would have already gotten an idea how your Spark SQL is pretty powerful. You can write your SQL directly. So you can also create all of your SQL and run as part of your Python program. Okay. So next we are going to see how do you use the data frame writer to write data frame as a table. So you created a new data frame. Now you want to write it as a table, so that if you want to persist that data, right? So you import your PySpark. So PySpark.sql has this function data frame writer, right? So you have your distributed data frame sales info. So I'm going to say sql.dataframewriter, right? So I'm creating this data frame writer object, right? And then I'm saying partition by sales territory and save it as a table. So the table name is sales info python 1, format is delta, and if the table already exists, I'm going to overwrite it. So I'm giving the path as well. So the path, as always, is your database, the folder delta, the table, and your sales info python. So since it's not a database that gets created, right? So what actually gets created is a file in a particular folder, right? Because it is essentially connected to a big data storage, which is your Databricks FS, or it could be your Hadoop if you want to connect your Spark onto Hadoop, right? So how do we find out? So you go ahead and do a file system, do a ls and go to this path to see what has happened here, right? So because that is the path we specified. So if you go and look at this, so you will see that this table has been created. So it says save as table sales info python 1. So the equivalent path in which the data corresponding to the table is present is this path. So since we say partition by the sales territory key, so there are as many files for each territory key. We have just made sure it is a particular file, right? So there is territory 1, 2, 3, 4, all the way till 10. But of course, since the sales info is created, you can also query it as a SQL. So in this demo, we'll continue to talk about PySpark data frames and data frames method. So in the earlier video, we looked at how do we translate your SQL that we have written as your Spark SQL using your PySpark. But now we are going to look at how can we directly create a Spark data frame from your CSV file. You don't have to load it into a data table and then create your data frame. You can actually directly create a data frame, right? So this is what this is all about. So we are creating a data frame. So all the variables which start with SP are Spark data frame, which means it's a distributed data frame. So we are using Spark context.read. So the format is CSV. Then we are saying, hey, make sure the header is true. We are doing infer schema true, right? So we have seen one of the advantages of your data frame. It does infer schema, right, which is not there in your RDD. So and then we specify the path of the file itself, right? So both your files get done, and then you can use your data frame methods like drop NA, etc. So just to show you that what it creates is a PySpark uh, Spark data frame, right? So of course, if you are here without using header information and explicitly specifying a header, so if you say header equal to false, but we are still inferring schema for your fact internet sales reason. So then we say to data frame, right? You specify what are the names of the column. Okay. So here again, you are creating a Spark data frame. So I'm just going to show you so that what we have created, right? So if you look at it, because we said header is 0, the first row, it just creates it as the header gets created as a first row. Okay. So then, of course, you can go ahead and check what is the schema, what's the data type into which the column has gotten access into, right? So go ahead and check that. So then now you convert your Spark data frame to Pandas data frame if you want, right? So which is essentially to do any sort of analysis. And then here we are just showing, so you can either show or take to do action on your data frame. So then we are going to talk a little bit about the different data frame methods. So if you want to rename a column, right, you can on your data frame. So as I said, when you do a dot tab, you should be able to see all of the methods that are available, right? Some of them are attributes, right? Some of them are methods, so you can try them out, right? So columns just gives you all of the columns, whereas with column name is a method, right? Attribute just returns value, so it doesn't come with a bracket, whereas your method, you have to specify some arguments to it. So some of the very commonly used methods are your describe, very similar to your pandas describe, right? So if you want to describe, so it gives you a lot of statistics like the number of rows, what is the standard deviation, minimum, maximum value for all of those columns. So then you can also do a join two data frames, right? So you can either run it as a Spark SQL, creating a new data frame containing all the customer info, right? So you're first creating a data frame, customer. Um, so if you have already a CSV file, you can load it. But if here we are just running a query, right? You are running the query on your AW project database. And then you can essentially say that, hey, on your um, Spark data frame sales, you want to join your customer info data, right? And what is the condition? So all of it. So if you sort of look at, do a tab, you will see the documentation, right? So use your shift tab to trigger all the intelligence in Databricks so that you can, so what kind of join you want to do, inner, and then here what we are doing is doing a select of all the columns, right? And for all the columns, we are doing rounding of your sales amount, right? And then some of the columns are the round value is sort of renamed into sales rounded, where the order key, the filter value is given here. So let's take a look at the output, right? So here Of course, we are doing a limit 3 and doing a display, but I would like to show you sales rounded, right? Which is the rounded value of the sales amount column, and we have renamed it. Okay, and then we are only looking at order date beyond a certain value. So after that, you can of course do your database aggregation as well, right? So your sum, your count, all of that. So you can do it on your data frame as well. So your data frame dot you specify. So as we saw, aggregate functions are which work on a group of rows. So you have to do a group by on a particular column and then aggregate, specify what you want to aggregate. So you want to sum the sales amount and order by the sum. And here we are doing a display of it, so that's why it's going to also display. So because you do group by a compute decision, right? So all of the sales amount has been summed for each of the compute distance. So you can also do multiple aggregation. So sum of your sales amount, count of star is all of the other columns, average of the tax amount. So let's take a look at this. Right? So it's exactly the same. So in the first column, we had only the sum of sales amount. So here we are having your count, right? So your count is the number of rows that are there for this compute distance, right? In your Spark data frame sales customer, and this is the average tax for each compute. So you can sort of start seeing the correlation. So the smaller the compute distance, the tax seems to be a little more, whereas as it goes higher, it goes to 36, all of it. Okay. So then finally, this is another very interesting property, something called broadcast. So occasionally we may want to apply multiple operation to a particular key, right? So let's assume the data for each key is large. Then this operation would involve a lot of data movement because your data fundamentally is distributed, right? So remember that. So due to the performance of such operations across distributed node, sometimes the application lags or it even stops working. So an optimization way is when joining such big tables, right? You can broadcast some of the small tables to these individual nodes to perform the join, right? So this is part of the optimization. So we talked about the catalyst optimizer, right? So you can actually use the SQL function import broadcast. Then it basically we are doing a join of the broadcasted sales territory data set, right? How the join happens on the left, right? So this essentially is a way of optimizing your data processing so that there is not a lot of movement of data happen. You can actually send the sales territory information to all of these nodes, right? So that is essentially a way to look at it. Okay, so we'll look at user-defined functions in the next part.
So let's summarize what we have seen in this module. So we started this module understanding the difference between Spark and PySpark. Right, so PySpark is a wrapper that is built on top of Spark, and then we also saw the evolution from RDD to DataFrame and what are some of the differences. We talked a little bit about the Spark SQL execution plan, where there is a logical plan and a physical plan, creating a DAG in order to execute the computation. And then we looked at a demo of the PySpark data frames and data frame methods. Alright, so I will see you in the next video. Thank you.